Alright, so we want to take this example on projectile. Then I want you to look at the question properly. So when you're solving a projectile question, the first thing you have to do is to actually read through the question and see exactly what you are asked to do. So now we see this question: a stone is shot out of a catapult with an initial velocity of 50 meters per second at an angle of 30 degrees. Calculate time of flight, maximum height attained, and range. Now, from what we can see in this question, we are seeing angle of projection. So anytime you see angle of projection, let your mind first go to the fact that the thing is launching from horizontal. That means it's launching from an horizontal level. So starting from here, it's launching at an horizontal level like this. So that means it's launching at an angle. Launching that color. It's launching at an angle. $30. Good. So it's launching at that angle, 30 degrees. And because of that, the ball is going to go in this direction. The ball is going to go like this. Okay, good. So that shows us that this is a case 1 because it is launched at an angle. And what exactly is the speed that at which the ball was launched? So u is equal to 50 meters per second. So now we're asked to calculate the time of flight, capital T. We're also asked to find the maximum height attained by the stone rather. Then we're also asked to calculate for the range. So that's it. So what should we do? Now, you should have memorized this formula that we had in the previous video. Alright, now we'll actually calculate for time of flight. Time of flight. So what's the formula for time of flight? Time of flight is actually given as the formula 2u sine theta over g. Right? Good. And anytime you're not giving your g, anytime you're not giving this your g means acceleration due to gravity. And that is actually a constant 10 meters per second squared. That's if you're not giving, otherwise specified. Sometimes they give you as 9.8, sometimes 9.9, sometimes 9.78. But if they didn't give you the specification, just use 10 meters per second squared. Okay, so now let's find for our t. Our t now becomes 2 times, what's our u? Our initial speed, our initial velocity is 50 meters per second. 50, then times sine 30, that's our theta, 30 degrees, angle of projection, 30 degrees, then divided by g, that's 10. Okay, good. All right, so let's do this. We have 2 times 50, we have 100. Then what's sine 30? Sine 30 is actually 1.5. That's half 1 over 2. Then divided by 10. Of course, so 100 times half, that's 50 divided by 10, and 50 divided by 10 is actually 5 seconds. So it's going to take about 5 seconds for the stone to go up, travel down, back to the ground. Then we also have to calculate for maximum height attained. So for maximum height attained, what's the formula for maximum height? Maximum height is given as u squared sine squared theta over 2g. What's our u? Our u is actually 50 meters per second. 50 squared, that's 50 squared, then multiplied by sine. When you say sine squared, what they mean is that our theta is actually 30 degrees. So that will be sine 30 all squared. That's what they mean when it says sine squared theta, divided by 2g, 2 times 10. Okay, so we have h becomes 50 squared. 50 squared is 2500 multiplied by 1 over 2. Sine 30 is 1 over 2, then squared, then divided by 2 times 10 is 20. And that gives us 2500 multiplied by 1 over 4. That's 1 over 2 squared is 1 over 4. Then divided by 20. And so we're going to have this as 2500 divided by 4 divided by 20. Okay, and that gives us 2500 divided by 4, you have 625. Then divided by 20, what you get is 31.25 meters. So your maximum height is actually 31.25 meters. So that's the maximum height attained by the stone. Then we're going to go and calculate. I think the last one we asked to calculate for is the range. Yes, the range. So what's the formula for the range? What's the formula for range? Range is actually given as u squared sine 2 theta over g. What's our u? Our u is actually 50 squared sine 2 times, what's our theta? 30, then divided by 10. And you've seen that 50 squared is 2500 multiplied by sine 60, then divided by 10. So 2500 divided by 10, this one is 2 here 1, this one cancels 1 0, that's 250. So I have 250 multiplied by what is sine 60. Sine 60 is 0.8660, and so 250 times that, 250 times 0.8660, that gives us about 216.5 meters. So that is the range. So that's how to calculate for the range. So we're going to take another example in this video before we call it before we put an end to this lesson. It said that anytime we are solving a projectile question, we have to read through the question to see exactly what we are asked to find and what we actually calculated. Now, you see this example: an object is projected with a velocity of 10 meters per second from ground level at an angle x to the vertical. If the total time of flight of the projectile is 15 seconds, what is the value of x? Calculate the range. Now, an object is projected with a velocity of 10 meters per second from ground level. So that tells us that it's actually a case 1 from ground level. Tells us that it's a case 1. And one other thing that also proves that it's a case 1 is that at an angle. So that tells us that it's a case 1. Ground level, angle. Alright, so let's try to do this. So we have a ground level. Something is projected from the ground level. Okay, at an angle x to the vertical. So all of the things we're doing are actually to the horizontal. The first example we did was to the horizontal. This is to the vertical. So that means we have another vertical axis. Now the angle of projection is actually like this. Then it is x degrees to the vertical. Then do it like this: x degrees to the vertical. X degrees to the vertical. Okay, now then this is then projected up. Okay, good. Now the thing is how to calculate for x, but then remember that in the projectile formula we're always using angle to the horizontal. always using angle to the horizontal. Let's call that theta. Now, what is going to be theta? Remember that this is a right angle triangle, and if that is a right angle triangle, then this has to be 90 degrees minus x degrees. So that's the angle there. So that means if this angle here is 30 degrees, then this has to be 90 minus 30, that's 60 degrees. And if this is 50 degrees, then this has to be 40 degrees. So that will be 90 minus 50 will give us 40. So that's the idea behind that. Okay, so then we have the range from here to here. So that's what I have to calculate. So far, so good. All right, so first thing first, we have to first go and calculate for our x. And how do we do that? Remember that they said that the total time of flight of the projectile is 15 seconds. So that means capital T is equals to 15. So from our T, we could actually get our 90 minus x degrees. That's, let's call this, all of this is theta. Okay, now if you could remember the formula for time of flight is actually given as T equals 2u sine theta over g. Okay, now what are u? Now the question is projected with a velocity of 100 meters per second. So that's our u. Our u is actually 100 meters per second. Okay, good. Then we're going to have 2 times 100 multiplied by sine theta. What's our theta? 90 minus x. Okay, divided by g is 10. Now what's our time of flight? T. Our t is actually 15 seconds. So we're going to say 15 equals 2 times 100 is actually 200 multiplied by sine 90 minus x divided by 10. So this can cut out one of the zeros. That's 20 divided by 10 is 20. And so we have 20 sine 90 minus x. Okay. Then we're going to have 15 equals 20 sine 90 minus x. And so we can divide both sides by 20. So we divide both sides by 20, and so we have 15 divided by 20 is actually 0.75. 0.75, that equals to sine 90 minus x degrees. So I can take the sine inverse. I can say 90 minus x equals to sine inverse of 0.75. So that means if I divide both sides by sine, that's what it means. So you have 90 minus x equals sine inverse of 0.75 is actually 48.59, and that's approximately 48.6 degrees. Okay, so what's my x? So I can make x rated formula by saying 90. I take this to this other side and bring this to this other side. So when I bring this, it becomes minus 48.6, and minus now becomes plus x. And 90 minus 48.6, what you get is x equals to 41.4 degrees. So this is how we've calculated for the value of x. Our value of x is actually 41.4 degrees. And so we also have to calculate for what again? For the range. We also have to calculate for the range. So that takes us back to the formula for range. Our formula for range is actually u squared sine 2 theta over g. What's our u? Our u is 100. That's 100 squared sine 2 times, what's our x? Oops, sorry, we can't use our x. We have to use our theta. What's our theta? Theta is 90 minus x. 90 minus x. What's 90 minus x? 90 minus x is actually 48.6. 48.6. Remember, that's our theta. Theta is 90 minus x. We have it here. Just for clarification. Remember that we have to be using theta. So our theta here is 90 minus x. So we have this to be 10. Okay, so we have our range to be 100 squared is actually 10,000. Then times sine 2 times 48 that is 97.2 divided by 10. So 10 cancel one of these zeros, and so you have 100, 1000 multiplied by sine 97.2 is actually 0.9921. Yeah. And so basically what you get is R equals 1000 times 0.9921. What you get is 992.1 meters. So 992.1 meters is your range. So that's it. So that's the solution to this problem.